Hello and welcome to another video. So this time we're going to be talking about finding the volume of the solid that is generated when you rotate a curve or a line about another line. Well, you see my hand gestures. That's usually what you would do when you rotate. And you can see that you go around a circle, which gives an impression that no matter what you do, if you rotate something about a line and you go back to the original position, you generate something in the form of a circle. Now, if it's solid, it's a disc. If it's not solid, well, you just have the frame of it, which is just the circle. But most times, what we have are lines that are solid. So we're talking about the volumes of solids generated. And because a circle is involved, it means you're generating discs of several shapes. Let me give you an example. Let's say you have this graph like this, and you decide to rotate this line about this point. Well, this is going to go all the way like this and form a cone. But what you've seen is that you've generated several discs like this, many of them chopped up. You can line them up, line them up, line them up, line them up, line them up. So if you want to get the total, you just have to find all of it. Well, you have to integrate what you have here. But definitely what you have here will be the area of the first disc. So let's say it's this thick. It's as thick as this. It's going to be something like a can. Look at this. So assume that this was the first can. Well, what's the volume of this? The volume of this is area times height. Remember, that's the volume of a cylinder. Well, that's the idea for this. So volume is supposed to be the area multiplied by the height. Okay? However, this is assumed to not have a significant height because it's a very small portion that we take out for the purpose of this integration. So we say it is dx, which is usually the thickness. Why did we say it's dx? Why is it not dy? Well, it could be dy, it could be dx, but because we're going along the horizontal for this picture that I drew, you see the x is just a small change in x. That's why it's dx. But if you had a picture that went this way, then each of your slices is going to be dy. You see that? And then you're going to have the area will be equal to pi r squared. In this case, your r is going to be x because you're going along the x-axis. In this case, our r is going to be y because we're going this way. You can see it's just the length of your radius depends on the y coordinate. So that's the general idea for doing this. You just have to know the area of a circle, have to know whether you're doing dx or dy depending on what direction your disk is facing. So just imagine if your disk is facing up, which is the direction of y, your dx has to be, your thickness has to be dy. Let that be on your mind, okay? It helps you remember things. If my disk faces the x direction, then it's dx. If my disk faces the y direction, then it's dy. And you're good. Let's do it. So now that we have the entire idea put together, let's start with the first question, number 1. So another thing you want to know how to do is how to sketch any curve that you see. At least have an idea. It doesn't have to be precise, but know how to sketch it. So how do we sketch this? The first one. So firstly, we're going to do this. So this is our axis, and one of the lines we'll be dealing with will be the line y equals 0. You might want to recognize that immediately. So we'll be recognizing that this line is part of what we're talking about. And the second one is the line y equals 1 minus x squared. Well, 1 minus x squared is a parabola that is dragged up. You can see because it's negative x squared, it means it's facing down. But because there's a plus 1, you're dragging it up. So your curve is going to be something like this. So this is going to be the point y equals 1. So at this point is going to be 1. This point is going to be negative 1. This point is going to be positive 1. If you plot that point, you're going to see that. And if you know how to sketch your curve, that's what it's going to be exactly. just dragged up 1 point. If you didn't know what to do, just look for the intersects, okay? When x is equal to 0, which is at this point, what will y be? When x is 0, y is going to be 1, so that's why we know that point is on the curve. Then when y is 0, what will x be? Then that means 1 minus x squared is going to be 1. It's going to be 0, which means x is going to be negative and positive 1, which are the two values that we have. So this curve is just going to go here. Remember, it's supposed to keep extending down, but we're not interested in what happens down here because we're interested in the region that is bounded by this and this, which is this upper region, just the top part only. Okay, so, and that's what we're going to work with. So now we're going to rotate it about the x-axis. Well, this is the x-axis. We're going to rotate this top part, so it's going to go down this way. And you can imagine, if you rotate this, you're just going to have this down here, and it's going to be a solid. Okay, it's going to be a solid. It's going to be like a sphere. We know it's not perfect, but it's going to be like this. So you notice that this looks like several discs. If you look at this, it looks like several discs that you can stack up. Well, it depends on what direction you want to slice your disc. See, this is a good example of you choosing whether you slice it facing x-axis or you slice it facing the y-axis. You will always get a circle, or at least you'll always get a disc. So I'm going to make a slice of a disc from this. I'm going to make it similar to this. Let's slice a disc here. Something like this. So this disc that I just sliced out of this here, remember this is a solid. Let me just make this like this so you know that we're dealing with a solid here. But I just took out this disc from it, which looks like this. Well, this disc has a thickness of, because the disc runs from my left to my right along the x-axis, in terms of thickness, it is dx. So the thickness of this disc is dx. So we're going to go here and say thickness. We're trying to solve this now. So we say thickness is dx. Or we can say equals. Now, let's just say this, okay? Thickness is dx. Now, what is the area? Remember the area of any disc, because it's going to look like this if you're looking at it from this direction, okay? The area of this is going to be, or you're looking at it from, it depends on what direction you want to look from, it's going to be pi r squared, okay? But what is the radius of this disc? Remember, this disc looks like this. Right now, the radius runs from the center up. Okay, and that's in the direction of y. So you can actually say that this implies pi y squared. Okay, now we're done. We just need to use our formula to integrate what is A and what is B. Well, because of this is what determines what your A or B is. You will be integrating with respect to x because it's in the direction of dx, okay? So what you want to do is write that the volume is going to be the integral from A to B of your area. Remember, that's our formula. What's the area? The area is pi y squared. And what's the thickness? The thickness is dx. What is A and what is B? Well, what are the limits? Where does our solid start from? It starts from the point where x is -1 and it ends where x is equal to 1. So it's from -1 to 1. And this is the setup. However, we're not done because we cannot integrate y with respect to x. You see that? So you have to change, because this is what you cannot change. This one has to be replaced with an expression in terms of x. So how do we do that? Where is the expression for y for question number 1? Remember, we're solving this one. Well, we know that y is equal to 1 minus x squared. So I can actually go here and replace this and say this is the same thing as from -1 to 1 of pi 1 minus x squared dx. So with this done, we can just integrate this, okay? I'm just going to expand this a little bit because I want to explain just the concept here, and then I'll give you the answer. So this is going to be the same thing as, well, because this is a parabola, and a parabola usually, well, all parabolas have this sense of symmetry, okay? They have a line of symmetry, which means the left-hand side is exactly the same as the right-hand side. As you can see in this solid, the left-hand side is just half of the entire shape. So you could as well take your integral from x equals 0 to x equals 1. And whatever you get, you multiply it by 2, and it's going to give you the entire figure. So that's what we're going to do here. Instead of us substituting -1, 0 is better to, or easier to substitute. So we can easily say this is 2 times, I can drag this pi out, okay? And say this is the integral of 1 minus x squared dx. But now, because I've multiplied it by 2, it is from 0 to 1. It's from here to here. I just double it. Okay, so let's clean this up. Let's see if we can clean this up. This is going to be 2 pi, the integral of 0 to 1 of, if you expand this is going to be 1 minus 2x squared plus x to the 4th. And then you integrate it with respect to x. Well, if you take this integral and you work on it, your answer is going to be 16 pi over 15. That's what you're going to get. Okay, it's going to be 16 pi over 15. Okay, now, should you leave your answer like this? No, because when you take volumes, it's a cubic measure. So always say cubic units or units cubed. Whichever one you choose, that's your business. But I just like to write it this way: units cubed. Or you can say 16 pi over 15 cubic units. Well, this sounds fancier, but it just takes longer to write. Maybe some 10 nanoseconds. It's okay, but that's what it is. So that's the first example. We're gonna go and solve the second question. So for the second question, a very important thing for you to know is that your ability to identify what function you're given, okay, will make it faster for you to sketch the curve and solve the problem. For example, I quickly knew that this was a parabola because I know that. Now, if you look at this, you can tell that this is a circle. How do I know it's a circle? Let me just briefly rewrite this and show you what I see. So if I rewrite this, you're gonna have y squared equals 25 minus x squared, which transforms into y squared plus x squared equals 25. This is the typical equation of a circle, okay? Now, what is the center of the circle? What is the radius of the circle? You have to be able to generate that from here. If we divide both sides by 25, what you're gonna have will be y squared over 25 plus x squared over 25 equals 1. Well, now the square root of these will be your radius because they're exactly the same. So the radius of this is the square root of 25, which is equal to 5. Now, what is the center of the circle? Well, the center of the circle is y minus h squared over 25. And then if you rewrite it that way, to be, this one would be x minus 0 squared over 25 equals 1. So you see, with writing it this way, I have generated the center. The center of this circle is 0, 0. So it's a circle at the origin. The radius is 5. With that, I have virtually solved this problem. So your skills from pre-calculus or algebra 2 will be very, very relevant in this question and in this topic generally. You need to know how to sketch curves. Okay, without that, you're gonna struggle with this. Okay, let's go on. So this is what I recommend. I recommend that when you want to solve this kind of a problem, start with the straight lines and then you can put the curve on it. And that helps you a lot because you don't have to struggle with the entire picture. Okay, so for me, I'm gonna start with the line x equals 2. I know the line x equals 2 has to be somewhere here. So let's say this is 1, 2, 3, 4, 5, 6, 7. The line x equals 2 has to run this way. So this is the line x equals 2. Also, I need the line x equals 4. Well, this would be the line x equals 4. So it runs this way also. I'm just going to write x equals 4 here. So what's the third thing? I need this equation, and that's a circle. Remember, we said this is a circle of center 0, and the radius is 5, which means I have a circle that starts from here, and let's say 1, 2, 3, 4, 5 also goes that way. So the circle is supposed to go like this. Okay, that's a terrible circle, but you know what? I don't need the rest of the circle. The part I need has been generated. Okay, it doesn't matter how good your circle is. We don't need the rest of the part. You only need the part that is enclosed by x equals 4, x equals 2, and this expression. So the only parts that are relevant right now, look at them. Let me erase this part, are just the parts here from this region to this region to this region and down here. That's it. So this is the part that gets rotated. So if this is rotated, see what's going to happen? It's going to go, let's get 1, 2, 3, 4, 5. It's going to be an exact mirror image of what you have there. So this is going to be somewhere around here. Basically, this is the shape that would be generated, but it's going to be a solid. So just do something like this. Okay, that tells you it's a solid, and we can do this also, just a little one, tiny bit and tiny bit. So we have generated the solid, okay, that showed up because we rotated that part that we generated from the beginning. And remember, now you don't even need to slice anything, because if you look at this from this side, you're gonna see a disc, okay? If you look at this from this side, you're gonna see a disc. So let's take out one of those discs, and I already took out one of the discs here. Okay, so I'm not gonna draw it again. We're just gonna use this as the disc. Now, what direction are you looking at it? Where is it facing? Well, it's facing the x-axis, not up and down. It's going from left to right. That's where it's facing. So you know your thickness will be dx. If it faces the x-axis, see how it sounds? Faces the x-axis, then it's dx. So we know the thickness has to be dx. I'm just going to write my formula. I don't want to bother myself. This is always there. So when you take a test or you solve a problem, always have this written down somewhere when you're using the disc method, because you don't have to repeat the whole process all the time. Now, remember, because you're doing, your thickness is dx, okay? I'm going to write dx here. That's already settled. Because it's dx, I'm writing my boundaries have to be in terms of x, which means from where this starts to where it ends. Where does it start? It starts at x equals 2. Where does it end? It ends at x equals 4. So I'm going to write 2 here and write 4 here. Now, what is the area? The area is pi r squared. I have to figure out what my radius is. Remember your radius, so again, maybe I should make a sketch of this. So this is your radius, okay? This is your thickness, dx. Your radius, because it goes along the y-axis, your radius is y. And that's it. So come back to the equation and write your area, which is pi r squared. You write it as pi y squared dx. That dx is too far away. Let's bring it closer, like family. Okay. So that's it. Now remember, you cannot integrate y with respect to x, so you have to change the expression y squared to something in terms of x. So we go back to the original expression, and what would y be? Y squared be? Well, remember what I did at the beginning to establish that this was a circle. We established that if you square both sides, you're going to have y squared will be equal to 25 minus x squared. That's what I'm going to write here. So I'm going to go back here and say this is the integral from 2 to 4 of pi times, what is y squared? Is 25 minus x squared. 25 minus x squared dx. Take out the pi and integrate. That's going to be equal to pi integral of 2 to 4 of 25 minus x squared dx. Well, you know what? I can actually integrate this. Let's get to the end of this one, and then I'll let you go. Okay, and then this is going to be pi, and if you integrate this, you're going to have 25x minus, this is going to be x cubed over 3. And then you put the limits there, that's going to be 2, and this is going to be 4. Never forget the disk and the direction the disk is facing. That's what tells you the thickness and if it's dx or dy. Hope you learned something in this video. If you did, give it a thumbs up. And don't stop learning, because those who stop learning have stopped living. Bye-bye.